In this video, we're going to take a look at the many different ways that we can use systems of equations and inequalities to solve real-world applications. So basically, how can we take a look at a problem, define two variables, set up a system of equations relating those two variables, and then use our knowledge of systems to find those two values. So, take a look at this first question. We want to know which situation of the four options below could represent the system x plus y equals 2.25 and 5x minus 2y equals 1.50. Go ahead and pause the video, and once you have an answer, start it back up again. Our correct answer here is choice C. Ooh, the pen's going crazy. So in this one, we have two variables. We have pen cost, which we'll say is x, and pencil cost, which is y. And when Spencer bought one of each of those, his total cost was $2.25. We know that the cost of 5 pencils is $1.50 more than 2 pens. So if I take away the cost of 2 pens, my difference will be $1.50. If we look at option A, we could have apple plus banana equals 2.25. So that could work. But then if we look at our next equation, we would have 5 apples plus 2 bananas equals $1.50. So that one's no good. For choice B, a large bag of chips costs $2.25 more than a small bag of chips. So this would if we did x minus y equals 2.25. So our first equation doesn't work there. And then for D, neither of those kind of really work for the equations that were given. So we're going to follow the same 3 steps every time we go to solve one of these problems. We're going to start by defining our variables. Then we're going to relate those variables in a system of equations. And then finally we're going to solve the system. So the only thing that's really new today is reading a problem and being able to set up the system. Once you have your system, you're going to be able to use whichever method you prefer, graphing, substitution, or elimination, to solve. You can use the calculator to check, but you still need to be able to solve the system by hand. So take a look at the question below, read over it, and see if you can identify anything that might be important there. Alright, so reading over this, there was lots of important stuff that we needed to know. The first is, how long is our trip? So our trip's going to be 7 days, and it looks like we're being asked about splitting our time between Tampa and Orlando. So we don't know how many days we're going to spend in Tampa or Orlando, so I'm going to say that X is going to be days in Tampa, and then I'm going to say that Y will be my days in Orlando. So now we need to look at the information we're given and think about how we can relate these two variables together. The first piece of information is going to be my 7-day trip. So this is going to be my first equation. The number of days I spend in Tampa plus the number of days I spend in Orlando has to be equal to 7, because we know that that's as long as we're going to go. We're not going to go any longer than that. Next, we need to figure out our cost. So this is going to be our second equation. If we spend $275 per day in Tampa, then 275 times the number of days in Tampa, or X, added to $400 times Y, the number of days in Orlando, will give me my total cost, which is $2,300, my budget total. Now we have a system of two equations, which by this point we're pretty comfortable with solving. So go ahead and pause the video and see if you can figure out how many days we should spend in Tampa and how many days we should spend in Orlando. Alright, so once we got our system set up, we've already done the hard work. For this one, I opted to use substitution. Again, you can use whichever method you prefer, and even if you use substitution, you may have done it differently. Either way, we end up with 4 days in Tampa and 3 days in Orlando. And this is why it's so important to define your variables, because we just end up with y equals 3 and x equals 4. And I have this key over here that tells me what each of those variables mean. It's also going to be really important that you label your answer with units. So if I just said 4 days and 3 days, I don't know what's what. So you always want to make sure that you give your answer with the appropriate level of detail or units needed for the problem. Alright. Go ahead and pause the video and see if you can set up the system of equations for this problem. Alright. So if we look here, we've got our important information. If you haven't set your system up yet, this is what we're looking at. I'm going to use different variables just so we can kind of keep things interesting. We'll use B for the cost of 1 bagel, and we'll use M for the cost of 1 muffin. Again, you can use X and Y if you want. You can use different variables if you want. Not a bagel again. We want 1 muffin. Okay. So now we have 2 different customers who have bought different combinations of bagels and muffins, and this is probably the most common application of systems of equations that you'll see, where you have different combinations that give out different totals or different costs, and you're trying to figure out how much of each cost or how much of each item is in those combinations. So for our first customer, we have 3 bagels and we have 4 muffins, and they paid a total of $5.67. For our second customer, we had 5 bagels and 3 muffins for a total of $6.70. And again, now we've done the hardest part. We've set the system up. So go ahead and pause the video and see if you can find the cost of 1 bagel and 1 muffin. Alright, so once you get our system set up, again, it's up to you how you want to solve. I opted to use elimination to eliminate B from the system. And that first gave me the cost of 1 muffin at 75 cents. Then we can substitute that back into either equation, and we get our cost of a bagel, which is 89 cents. Alright, go ahead and see if you can solve this problem. Remember to keep in mind your place value for the different amounts of money. A nickel is 5 cents, and a dime is 10 cents. So go ahead and see if you can set this one up, solve it, and get your answer. Alright, this one's kind of tricky because we have to remember how much money a nickel is worth and how much money a dime is worth. So that can give us our first equation. Before we do that, we want to define our 2 variables. So we have N and D, number of nickels, number of dimes. Again, you can use whichever variables you want as long as you define them. So we know that she has a total of $4.50 between the nickels and dimes. So each nickel is worth 5 cents, or $0.05. So we multiply that by N. And each dime is worth 10 cents, or $0.10. So we multiply that by D, and altogether that's $4.50. Then the second part we have here is that the number of dimes is twice the number of nickels. So my number of dimes, which is represented by D, is going to be equal to twice the number of nickels, or 2N. So this system actually sets itself up rather nicely for substitution, since equation 2 is already solved for D. You can take that 2N, substitute it right into the second equation and solve, but again, if you did it a different way, that's okay. You're still hopefully going to end up with the same solution. And at the end, we see that she has 18 nickels and 36 dimes. Alright, this next type of question is probably one of the most challenging that we look at, and these are the mixture problems. They're just challenging because they're a little different than stuff that you may have worked with before, and there's a little trick to setting them up. This table in the top here is going to help us as we go to set up our equations, and when you work on mixture problems on your own, I encourage you to set these tables up. So we have a metal alloy that is 25% copper. An alloy is a combination of different metals used to make a new type of metal, and this one, 25% of that is copper. So that's going to be important. Another type of metal alloy is 50% copper. So usually when we deal with mixture problems, we're talking about the concentration of one type of element or liquid or chemical in terms of a larger solution. And we want to figure out how much of each we need to add to make a certain solution, or in this case, a certain amount of a metal alloy. So we want to make a total of 1,000 grams of an alloy that is 45% copper. So there are 2 things I'm dealing with here. I'm dealing with the total grams, or the total mass of my substance. In this case it's grams, it could also be ounces, gallons, whatever. And then the amount of copper that is in that solution. So my first equation is an easy one. We know that altogether we're going to have 1,000 grams. So I'm going to first define X to be my grams of 25%, and Y is going to be my grams of 50%. So obviously if I add the 25% alloy to the 50% alloy, it's going to dilute it a little bit since there's less copper in the first one. So when I add those 2 together, I want to get 1,000 total grams. So this is where our chart comes in. We're first looking at just how many grams do we want to end up with. We're going to take, in this case I'm going to use X and Y, X grams of 25% copper plus Y grams of 50% copper. And altogether, that's going to give me my total of 1,000 grams of copper. The next equation is the one that's a bit more difficult. This is where we start to look at the actual amount of copper. So in the end, we want to end up with 1,000 grams of 45% copper. So we need to figure out how many grams of that end result is actually copper. So we really want 45% of 1,000. In order to find that, we take 0.45 and we multiply it by 1,000, and that'll give us the amount of copper in our alloy when we're finished. And so we know that we'll end up with 450 grams at the end. So that's going to be our total when we're done. And that's what this part is going to be equal to here. So now we look at the two things that we're adding together. In order to figure out how much copper is in the 25% copper amount that we're adding, we're going to take 0.25 and multiply it by the number of grams. So if I had 100 grams of this alloy, 25% of it is copper, which means that 25 grams would be copper. But we don't know how much we're going to have, which is why we use the variable. Then we do the same thing with the other alloy that's half copper, or 50%. So if I had 10 grams of this alloy, 5 of them would be copper. If I had 1,000 grams, 500 would be copper. So here we just want 50% or 0.5 times y. So once we've got our system, even though it was a little bit complicated to set up, this problem actually becomes fairly simple. Go ahead and pause the video and see if you can solve the system. Alright, so once we solve our system here, we end up getting 800 grams of 50% alloy and 200 grams of 25% alloy. Okay, so here's another mixture problem. And to give you a clue, because I'm going to have you guys try this one on your own, I'll help you set up the table. So we're looking at how many gallons of milk we have to add together of two different mixtures to create 2% milk. So we have a low-fat mixture containing 1% fat and whole milk that has 3.5% fat. We want to create 100 gallons of a 2% fat mixture. So this is going to get kind of gross, but here we're going to talk about gallons of milk and then how much of that milk is actually fat. So I'm going to make a kind of gallons of fat entry here, which is really kind of gross when you think about it, but that's what we're going with. So then we have our 1%, we have our 3.5%, and we have our total. So if you think about our variables, we can use x to be gallons of 1% fat, y will be gallons of 3.5%, and we want to think about what sort of system we can set up here. Pause the video, and before you solve it, come back to see if your equations are correct. Alright, so if we take a look here, we know that at the end of the day, we need to have 100 gallons of milk. Ooh, pen's going crazy. So, that means that the gallons of 1% plus the gallons of 3.5% have to equal 100 total gallons. Now, this is where it gets a little yucky. We're talking about the actual amount of fat in the milk. So if my low-fat milk is a 1% solution, that means that 1% of what I'm drinking there is fat. So if I have 100 gallons of just this, I'm going to have 1 gallon of fat in there. So we take 0.01, because we want to convert that to a decimal, and multiply it by the number of gallons of 1%. We add that to 0.035 times the number of gallons of 3.5%, because that'll tell us how much fat is there. And altogether, we want to have a 2% mixture. So 2% of my 100 gallons that I'm done with is going to be pure fat, which is kind of gross, but it is what it is. And so 2% of 100 is 2. So here is our system of equations. Go ahead and pause the video and see if you can solve that. Alright, so when we solve this one, again I use substitution, but you're free to use whichever method you prefer. We end up with 60 gallons of 1% and 40 gallons of 3.5%. Alright, so here's just a typical SOL type question you might see. Go ahead and read over the problem and see if you can select the correct answer. If you selected C, you had the correct answer. If we look at our equations here, we have a total of 243 adults and children, which means that adults plus children has to equal 243, and all of our answer choices had that equation. So unfortunately, we can't eliminate anything there. Next, we knew that there are 109 more adults than children. So if I take the number of children and I add 109, I will get the number of adults. And where we see A is equal to B plus 109 is in choice C.